As we continue our conversation on multiplying multi-digit whole numbers, it's time to look at multiplying whole numbers in real-world scenarios. In other words, we're going to look at multiplication within a word problem. A lot of times word problems become a little bit of an obstacle for students because they don't exactly know what the word problem is asking them to do. And that's understandable because it is much easier to just take two numbers and multiply them or add, subtract, divide, whatever's being asked within some type of math equation. However, this real world scenario provides us an opportunity to link math with the real world. So what I'm going to do in this lesson is we're going to use an example word problem to walk through how we look at the word problem, what information is important to us, what relationships we establish between the two numbers, and then we'll come back around at the end and solve the problem and reinforce some of the processes that we've already put in place earlier this week. So if we could, let's go ahead and take a look at our example word problem. It says a comet flying through space travels 2,534 miles per second. In 56 seconds, how many miles will the comet travel? So this is basic information here, and what we need to do is kind of think through what's been given to us. Now, what I do know is that 2,534, and I'm going to put m/s, miles per second. I know that. In other words, what I know is for every 1 second that my comet here in the story is going to travel that far. But the problem really finds itself in the second part of the word problem. It says in 56 seconds, how many miles will the comet travel? So what we really know, and I can clean this up a little bit, I know some certainties. I know that it goes 2,534 miles in 1 second. What I don't know is how far would it travel in 56 seconds. And that really becomes the missing information that I'm asked to solve here. Now, one could say I could set and just let's add this over and over and over again. So if that's 1, I could add another 2,534, which would, the sum of those two numbers would give me 2, and I could continue to repeat that process until I've done it 56 times. And folks, what that is that's the core of what multiplication is. Multiplication is repeated addition. But can you imagine how long it would take me to add those numbers 56 times? And that's why multiplication could be said on one hand to be just a much more efficient way to add numbers together. So what we see in the word problem is it's giving us what it does for every 1. And you're going to see that with the multiplication problem. It says hey, and let me erase this so I can kind of focus in on the 2,534. It gives us this. For every 1, something happens, whether it is miles traveled, it could be we make 2,534 iPhones per hour, whatever it is, it's going to kind of give you what I would say a unit rate. How much does it do per 1 of something? But then the question will kind of flip and say, but I don't really want to know 1 because I've given you 1. I want to know 56. And so when we see that, we see an opportunity to be repeated addition, we want to say, okay, that's multiplication. Now what I want to do is go to, when it's time to solve, I'm going to go to the standard algorithm, 2,534, and it's going to be multiplied by 56. Well, because I'm going to use the standard algorithm, I know that the first step is to line them up. Oops, little mistake there. I'm going to line them up by place value. And that's hugely important. And notice that my 1s are on top of my 1s, 10s on top of my 10s, and obviously for the hundreds and thousands place, I don't have anything below that. And then when I begin the process, I'm going to begin by multiplying everything in the top number. So each of those 4 digits need to be multiplied by the 1's place in my second factor given. So the 6 is going to multiply by the 4, 3, 5, and 2. And we want to work in that order with the 1s, 10s, hundreds, and thousands. And that's the process of the standard algorithm. So I'm going to go 4 times 6 is 24. I just dropped the 4. Remember, I can only bring down one number at a time unless it's the last number that I'm multiplying in the series. Then I'll regroup the 2. Then I always multiply before I add my regroup number. 3 times 6 is 18, plus the 2 is 20. So I'm going to regroup the 2 again. Then I go 5 times 6 is 30, plus 2 is 32. And I'm constantly regrouping. 2 times 6 is 12, plus 5. And then here's the scenario. I can't regroup that one because there's nothing to regroup it to. Then I'll put it there at the front. And what I know is this represents 2,534 times 6. But I'm not finished yet because I need to deal with the tens place here. So I need to now multiply everything by 5, but really because of our place value understanding, we know that's not a 5 because it's in the tens place. It's a 50. And to honor that multiplication-wise, we want to put a placeholder 0 right there in the ones place. And then just to make sure I don't make any mistakes, I'm going to come up and mark out any regrouping that I've done from the first round just so it doesn't get in my way. And just as I did with the ones place or the 6, I want to make sure that I multiply every digit in the 2,534 beginning with the ones place. So I'll start with 5 times 4 is 20. Regroup the 2. 3 times 5 is 15 plus 2 is 17. Regroup the 1. 5 times 5 is 25 plus the 1 is 26. Regroup the 2. And then 2 times 5 is 10 plus the 2 is 12. And that is my second partial product. And because I have two partial products, I definitely want to add those together. So I know that that is 2,534 times not just 5, but 50. So I have the two partial products. In order to make those one product, I'm going to add them together. Again, more single-digit basic mental math coming at me. So 4 plus 0 is 4. 0 plus 0 is 0. 2 plus 9 is... I'm sorry, I said the answer first. 2 plus 7 is 9. Then 5 and 6 together give me 11. There's some regrouping I have to do. 1 plus 2 plus the 1 is going to be 4. And then there's nothing there at the end. We just want to drop the 1 down. I want to place my comma to keep families together. And then the last thing that I really want to do is kind of come back to the question and look for a unit. It's not just 141, 904. It's 141, 904 miles. And so it's really important that we label our work so that it matches our word problem. And so this is how we solve. And then the other focus today is looking at the question and seeing how it's multiplication. One of the things that I'm going to really ask you to get away from this year is not looking for just these cue or key words that just automatically say, well, that's addition or subtraction. And the reason I would say that is because since multiplication is repeated addition, there's a strong bond between those two. And a lot of times, the words that you might be swayed to think, well, this is an addition problem, well, they may show up in multiplication since they're really just an extension of each other. One could say that multiplication is just an extension of the addition, in which it is, which I would wholeheartedly agree. So this is our lesson for today. Today you're going to see some word problems. As you practice them, we definitely want to make sure that we are doing the work on paper, that you are keeping some of those good habits in line. I cannot stress the importance of using graph paper, placing one digit in each box so that it keeps things lined up. I also can't stress enough the importance of working on those basic facts. And if this is something that's a little bit rusty for you, please use whatever tools are available to you to improve that skill. So here's our lesson. Good luck on the practice, and I'll talk to you soon. Take care.